Hello friends, welcome back. In the last part we covered general formula for division. In this part we will take a step further to see the factorization. So let's start. So in here you see the simple quadratic equation and we need to find the factors of it. So let's say equal to would be the final answer. So now the step 1 would be to split the middle term into two parts so that the ratio of coefficient of first term to the first factor, let's say we call it A, equal to ratio of second term divided by the coefficient of the last term, wherein A plus B shall be equal to 9, which is the coefficient of the middle term. So now which all terms or which all numbers would satisfy both these conditions? So A plus B shall be equal to 9 and A into B, let's say AB shall be equal to 20. If I do like this, so like all numbers will multiply to 20. So 2 times 10, but they don't sum up to 9. 4 plus 5, yes they do, or 5 plus 4 they again do, but yes, apart from them no other two numbers whose addition will turn to 9. Of course you can have 20 times 1, but that again doesn't sum to 9. So that means like the two terms that we are talking are 4 and 5. So, and if we do like this, let's say 2 divided by 4 equal to 5 divided by 10. So 1 by 2 equal to 1 by 2. So that matches our both conditions, ratio as well as the sum. So the first factor is the ratio itself. So if we can write down x plus ratio is 2. So the thing to notice is if 1 by 2 means the second term is 2. If it is 2 by 1, then it's 2x plus 1. So that is our first term. Now for the second term, what we do is that we take down the first term of the equation, 2x square, and then divide it by the first term of the factor, which is equal to x, plus last term of the equation divided by the second term of the factor. So that is this one. So now this itself equals to the second factor of the equation. So what this translates to? This translates to 2x plus 5. So that is our second term of the equation. So that's how you do it. Let's look at another example. Again, we do normally. Let's say here we will write our final answer. So first we need to do the coefficient of the first term, 3 divided by, let's say, some hypothetical number a equal to b divided by 2, and the second thing should be a plus b shall be equal to minus 7. So which two terms who will sum to minus 7, and whereas their multiplication is 6? So I would say minus 6 and minus 1. So they sum to minus 7, and their multiplication minus 6 into 1 goes to plus 6. So if I write down 3 divided by minus 1 equal to minus 6 divided by 2. So that gives us the ratio minus 3. So if we take the ratios minus 3, so the first term will be minus 3x plus 1. Now for the second term we can do the division. So 3x square divided by the first term of the factor plus last term of the equation divided by second term of the factor, which in turn gives us minus x plus 2. So our second term is minus x plus 2. This in turn can also be written as, because if we take out both minus signs and change the signs, it can be 3x minus 1 into x minus 2. So both are kind of like same solutions to the equation. Let's look at another example. So in here, let's do the same thing. So in here, what we are looking at is that 6 divided by a shall be equal to minus b divided by minus 19, wherein a into b shall be equal to minus 13. So now 19 times 6, and where the sum of these two terms be minus 13. So if you look at this equation, the answer lies in the equation itself. So the terms will be 6 and 19 themselves. However, then their sum would be minus 13. So the higher term would be minus 19 and the smaller term would be plus 6. So let's write it down this way. So it would be 6 divided by 6 equals to minus 19 divided by minus 19. So both these conditions are satisfied. So our first term would be the ratio, so it would be x plus 1, and for the second term of the equation, if we do 6x square divide the first term of the factor plus in fact the minus 19 divided by second term of the factor, which in turn gives us 6x minus 19. So our second term would be 6x minus 19. Let's look at another example. So here, if you see, it's a slightly different variation of the previous type quadratic equation, in a sense that is a homogeneous equation. So if we say that x is the first factor and y is the second variable actually of the equation, so then we can do the same technique. So for the first factor, we need to divide 15 divided by, let's say, a something, which gives us b divided by minus 8. We'll come to the x and y just in a short while, and wherein a into b equals to minus 14. So the terms that satisfy this are 20 and 6. So our factors would be minus 20 and plus 6. So they satisfy both these conditions. So if we do it this way, so 15 divided by 20 gives us actually it's minus, so we write minus here, gives us 6 divided by minus 8. So our ratio translates to minus 3 divided by 4. So our first term of the equation is minus 3x plus 4y. Now for the second term, if we divide this 15x square divided by minus 3x plus minus 8y square divided by 4y. So what that gives us is, actually I will put bracket here so that it's clear. So what it gives us is minus 5x minus 2y, which if we take out the minus sign out, so that gives us 5x plus 2y, and then we take out the minus sign out from there as well. So the first coefficient if we write it down like this, which is minus and 5x plus 2y, or I can write it down like this, 3x minus 4y and 5x plus 2y. So that's the answer for this equation. Now let's look at another example. So now here what we are looking at is an inconsistent equation which contains which is like a quadratic for both x and y, and also contains terms which are not homogeneous, for example 2x and 5y, that way. So now how do we solve this particular case? So here first step is, if you put x equal to 0, let's say, then what this equation will be. So it will be, because let's say y is 0, so then what this will translate to, 2x square plus 5xy would turn 0 plus 2x minus 12. So that's our equation number 1. And then if we put, I would rather than right here, and if you put x equal to 0 similarly, then what we'll get is this 2y square minus 5y minus 12. So these are the two normal quadratic equations that we need to solve here. So let's do the first one. For the first one, it would be, the conditions are there, a basically divided by a shall be equal to b divided by minus 12, and a dot b should be equal to 2. So the things that we are looking at, that are numbers where a times b is minus 24 and their sum is 2. So I can think about because the higher number is positive, so it would be 6 and minus 4. So terms are 6 comma minus 4, and then so the ratio would be 2 divided by 6 equal to, so 2 divided by 6 equal to minus 4 divided by minus 12, so it's 1 by 3. So the first term is, let's say, x plus 3. Now keep in mind that this is the solution for this one, so I will write it down here actually. So x plus 3, and I'll keep this bracket open so that we can put the file down after our adjustment here. And the second term in this case would be 2 divided by 2x square divided by x plus minus 12 divided by 3, which gives us 2x minus 4. So that's our second term for the first equation. Now if we do the same way for the second equation, similarly I just solved the second equation, which is 2y square minus 5 minus 12. So if here, what we are looking at is the ratio of 2 by, say, term c should be equal to t divided by minus 12, which gives us c, and with the multiplication c into d as minus 5 plus actually. So what it gives us is like those two factors are minus 8 and 3, which with the ratio gives us is like 1 minus by minus 4. So our first term would be y minus 4, and if we divide that factor with the first and the last term of the equation, so what that gives us is 2y plus 3 as the second factor. Now here if you notice that x plus 3 and 2y plus 3, they have the 3 common. So definitely in this first factor, the last term shall be plus 2y. Similarly, here if you see minus 4 is common in this and the last second factor of the first equation. So second equation, 2x plus 2x minus 4 plus y. So that's our second term. So this is how you solve equations of this type. They look daunting at first, but when you do the replace one term with 0, then it becomes like a normal quadratic equation, and then you can apply the same technique to solve them. So in this video we have seen how to you do the factorization of different types of equations. We will see with you some interesting topics soon in the upcoming videos. For the time being, practice multiplication and division using various techniques that we have discussed in this and previous videos. Have great fun learning. Bye for now.